Hello. In this video, I'm going to show you guys how to use Excel to manipulate data in order to figure out the trends on our periodic table. So far in class, we've discussed that the periodic table is arranged in a certain way. We've talked about how it's arranged by atomic number, how it's arranged by valence electrons, and now we're going to be talking about how it's arranged by ionization energy, electronegativity, and atomic radius. So electronegativity, we've talked a little bit about that already. We've said that it has to do with the pull for electrons. We talked about the tug of war, about how if we've got two electrons and they're both competing, or if we have two atoms and they're both competing for electrons, who would win in that tug of war situation? Ionization energy then is our second property of atoms that we're going to be looking at. And ionization energy, it's the amount of energy required for an atom to become an ion. And we know that that means that we would be removing an electron in order for it to become an anion, a negative charge, or it'd be gaining an electron to become a positive, or to be losing an electron and be negative. The last property is atomic radius, and the atomic radius is pretty much what it sounds like. It is the radius of an atom. So from the very center in its nucleus to its very outside electron. And we're going to be using Excel in order to figure out these trends. Does it increase? Does it decrease as we work across our periodic table? What does it do? So on Schoology in Unit 3, you have this data. It's a trends graph. And what we have here, I'll explain this to you really quick. So in column A, we've got all the elements listed from hydrogen to, what's my last one? Krypton. Okay, so hydrogen to krypton, I believe that is the first 36 atoms on our periodic table. Let me check that. Yes, so krypton is number 36, so hydrogen all the way up to krypton. All right, next we have their atomic numbers listed, 1 through 36. Yep. Then we have the ionization energy per atom, so how much energy it takes to remove an electron from each atom. Then we've got atomic radius, so the size of each of these. And then electronegativity, that's the pull of electrons for the pool of atoms for electrons. And electronegativity is there's not a unit for that. There's a scale. So our scale is 0 to 4. It's called the Linus scale. Scientists with the name Linus figured it out. And atomic radius, this is in picometers, so that's 1 to the negative 12th meters. This is teeny, teeny, tiny, smaller than a nanometer, really tiny. And then ionization energy, this is kilojoules per mole. Okay? So what we're going to do here, we are going to create some graphs of our data, and we're always going to be graphing our atomic number versus our property. So atomic number on our X, ionization energy on our Y. We're going to end up making 3 graphs here. Okay, so I went ahead and made 3 different tabs, right? One for each. So EI for ionization energy, AR atomic radius, and then electronegativity. So for ionization energy, I'm going to go ahead and copy this data to that tab, and I'm just clicking and dragging, select all that data. Control C is copy, go to EI, paste this over here, and now I'm ready to create my graph. So when you create your graph, we're just going to make scatter plot, so select only your numbers here. We're going to go Insert, make it a scatter plot, and there she is. I'm going to pull it up over here though so I can see it next to my numbers. Alright, I'm going to call this my ionization energy trend, and I'm going to put my axis titles on my X and Y. My X, this is atomic number. And for my Y, this is ionization energy. Okay? So that's awesome. Cool little graph, but we need to be able to look at this graph and see what it means. Okay? So our first data point, this is 1 and 1312. We know that 1 is hydrogen, and it has ionization energy of 1,312 kilojoules per mole. All right. Our next point is 2. This is helium, 2,373. So as we're moving across from hydrogen to helium, it looks like it increased. Let's check the next row. Let's go lithium, beryllium. So that's 3, 4, boron, carbon, nitrogen, oxygen, fluorine, neon. So 3 to 10. Let's check that. So here's 3. We're at 513. 4, 899. A little drop here. 5 is 801. 6, 1086. 7, 1402. 8, 1314. 9, 1681. And 10, 2081. So overall, we could say that this, across that second period, would be increasing as well. We'll go ahead and do the third just to make sure, but you can probably, whoops, sorry about that. You can probably already tell that, you know, just looking at this trend, this would be atoms in the third period on our table. Looks like it's going to be increasing. Here would be our fourth period. Now, remember on period 4, we've got these 10 in the middle to account for as well. Okay, so that's why you've got a lot more data points than you did on the first 3. So this is for ionization energy. You should be able to create the graph, define what ionization energy is. Use that graph to determine the trend as you move down a group, and then also as you move across a period. So I just showed you guys how to go across a period. You should be able to tell me, you know, across the period, does it increase or decrease? Well, as we could tell, you know, if we went across a period, it increased, right? Now, it also asks you to go down a group, so down a column. And if we look at column 1, okay, so group 1, we've got data points 1, 3, 11, and 19. So let's go check those out, 1, 3, 11, and 19. So here's 1, and 1 was 1312. Okay. Here is 3, and that's 513. So we've got 1312, 513. Here is 11, and 11 was 496. And then our last one, number 19, is 419. So you can tell that obviously as you go, down a group, down that column, what's happening to your ionization energy? Well, it's decreasing. So number 3 decreasing, number 4 it's increasing. On the representation of the periodic table below, draw arrows to represent increasing ionization energy. Okay, so you should be doing this with a pencil. I'll show you, you know, with just like a little arrow. Okay, we said across a period, it increases this way. So draw in that arrow. But as we move down this group, it got smaller. So if we moved up a group, it should get larger, right? So we're just going to insert an arrow, and you can draw yours on. But as you go up a group, our ionization energy gets larger, okay? So there's the first one for atomic radius and atomic electronegativity. You'll need to do the same thing. You'll need to create those scatter plots. Put your labels on there for your X and Y axis. Give the chart a label, and then you're going to need to analyze these charts and see if you can figure out what those trends are so that you can answer your questions. If you have any questions or if you need any help with Excel, please just let me know.